Okay, in class on Wednesday, we covered two different types of confidence intervals. We covered confidence intervals for the population mean. I'm going to highlight. I'm just going to put pop mean. Man, that is some bad handwriting. Alright, well, whatever. You're going to have to deal with it. So, confidence intervals for the population mean. That's what we did in class on Wednesday. We had two kinds. There's one formula that you use if your sample size was greater than or equal to 30, and that's the formula that used the ZC times standard deviation over square root of n to get your margin of error. If you had less than 30, that's when you had to use that different chart, the t distribution chart, to get your t value, and then times standard deviation over the square root of n. So both of those examples, those formulas right there told you what the margin of error was. We call that big giant E. So, if you have a proportion, though, remember those were about confidence intervals for the mean. If you have a proportion, that black type is not very easy to see, but it looks kind of groovy. So if you have a proportion, you have a third formula for E. You've already learned two formulas. Here's the third one. Okay, so the formula is, we're back to that Z critical value. Remember, that's a Z-score, but it's a critical value Z-score. So if we're doing a 95%, it's the Z-score within which 95% of everybody falls. So it kind of gives you the positive and negative Z-score where 95% of everybody is. And I'll give you what those are again. There's really only three that we use. So it's the ZC value times, and you got a bunch of stuff in square root. So it's p hat, we call it. Now that sounds like something that I would make up, but that really is the name. It's called p hat times q hat over n, and all of that is underneath that square root. So let's talk about what p hat is. P hat is just the proportion of your sample. So if you interview 100 people and 75 said whatever it is that you're studying, then your p hat would be 0.75. So that's just a proportion in your sample. Q hat would be its complement. So it's whatever p is and then the complement of it, 1 minus p. N, remember, is always your sample size. So that's your formula for finding the margin of error when you have a proportion in your statement. Okay, so a typical problem. Ooh, let's see if I can type while I talk. Although it's hard for you to see typing, but I don't want to write it all out because it's messy. Okay, hold on, everybody. Okay, so here's a typical problem. Ooh, that's better. Look at that. You survey 156 people and find that 57 love their math class. Find the, 95% confidence interval for the population. Proportion. Again, it's a proportion because we're not dealing with the mean. We're not dealing with the average number of people. Proportion. We're not dealing with the average number of people. We're dealing with a proportion. So let me scoot that out so you can see it all the way. There we go. All right, so that's what a typical problem looks like. I'm going to remind you what those ZC values are. So if you have a 90% confidence interval value, confidence interval, your ZC value is 1.645. That means if you went to a standard normal curve, that is a gross, sad face, ugly. If you went to, still kind of ugly, but I don't want to continue. Standard normal curve, 1.645 would be about here. That would be negative 1.645, positive 1.645 would be about here. And so that means 90% of everybody would fall between those 2 points. That's why it's called the Z critical value. All right, the 95% one. You can't even read that. I gotta pick up my game here. In order to write neat, I have to be slow, and that's annoying. 1.96 is the Z value that goes with 95. 99%, it's 2.575. You need to have those written down. Have them written down, put them in a big box, something so that you can find them, because you need to have them for all of the problems that you do. Okay, we're going to continue with this problem. So a confidence interval, if you remember, I'm going to erase these ugly things here so I can have room. A confidence interval, so you're telling me where the population of all students fall. I've taken a survey of 156 students, and I found that 7 of them, love math. But I want to know, okay, where's the population proportion falling? I can find the proportion of my sample. You're the rattlesnake. I can find the proportion of my sample. In fact, that's what we call p-hat. By the way, we want p-hat and q-hat in 3 decimal places, just so you know. So 57 divided by 156. I get 0.365 as my p-hat, which means q-hat is the complement. So that's 635. Ooh, weird dyslexic complement. So that's P and Q. So the proportion of my sample was 36.5% of everybody that I surveyed love math, but I want to know where the whole population is. That's what a confidence interval is. In order to do that, you have to find what's called the error. How far off might your sample have been? So you need the ZC value. That's our little formula, right? So we're back up here to the top of the screen. ZC value goes first. I have a 95% confidence interval. So my ZC value is 1.96. And I'm going to multiply that times the big giant square root. And I'm going to do my p-hat, 0.635, times my q-hat, you know what? I said 635, but it's 365. Okay, q, 0.635. And then divided by n, you can just go ahead and hit divided by. Don't do parentheses. It just makes things funky. N is how many total people you surveyed. It is not, for the love of all that's holy, 57. You surveyed 156. So all of that goes in the calculator. Please do it all in one step. Don't do it in pieces. You don't need even parentheses here. Do it all in one step. So I'm going to do that on my calculator while you, I'm sure, are doing it in yours as you listen. Oh man, my second button's stuck. Okay, hold on. Times, for the love of all that's holy, times square root 0.365 times 0.635 divided by 156. So you get an error of and I'm going to do my error in the same number of decimal places as P and Q. So if I round to 3, it's 0.76. That's my error. That means I can expect that my sample might be off as much as 7.6%. So I'm going to take that information and I'm going to finish the problem. Ugh. I wish there was a better way to move stuff. I'm sure there is, but it is what it is. Okay, start with p-hat, 0.635. That's the proportion of my sample. And then now, in order to get my final answer, my final confidence value, I have to subtract the error, and that's going to give you my low value of my sample. 8. So 28.9% or 0.289. So the actual population might be as low as 28.9%, or now you add the error, and that gives you the high value. So 1, 4, or it might be as high as 44.1%. So what I have done here is I've created the 95% confidence interval for the population proportion. Again, all you have is the sample information. That means the population falls somewhere between those two values. And the 95% confidence, there's 2 ways to think about it. Number one, you could say, well, I'm 95% sure the population falls there. Another way that they describe it is they say, if you took a sample, if you took 100 different samples, 95% of the time, you're going to get this same confidence interval. All right, so that's kind of another goofy way to look at it. But that's a typical problem for confidence interval for the population proportion.